Okay, this is section 4.2 and 4.3. We're going to find all the zeros. For example, g of x equals x cubed plus minus 2x squared minus 9x plus 18. Well, the first thing I do is I'd set this equal to 0. And now this is going to factor nicely as x minus 2 is in common to these two groups. If I factor out an x squared from this first group, and then a negative 9 from the second group, that's going to leave me with x squared times x minus 2 minus 9 times x minus 2 equals 0. X minus 2 is in common to these two factors. So I would factor that out, and that'll leave me with x squared minus 9 as the leftover. X equals 2, or x squared equals 9, means that x is equal to plus or minus 3. So in all, there are 3 zeros. Notice how the degree of the polynomial is 3. Okay. Next one, h of x equals x to the fourth plus 4x squared minus 45. Okay. So the first thing that I'm looking for in a degree 4 is if there's a common factor. There isn't. The next thing that I'm looking for is if I can make a u substitution. U is equal to x squared, so u squared would be x to the fourth. U squared minus 4u minus 45 equals 0. Okay, so u squared plus 4u minus 45 equals 0. That's a quadratic equation. So this is an equation that resembles a quadratic. We can see that by the u substitution. U minus 5 times u plus 9 equals 0. It'd be how that factors. And so u is equal to 9, or u is equal to 5, or u is equal to negative 9. U is equal to x squared. So x squared equals 5, and x squared equals 9. Negative 9. X squared equals 5 means that x is equal to plus or minus root 5. And x squared equals negative 9 means that x is equal to plus or minus the square root of negative 9, which is plus or minus 3i. Okay, now it says to find all the zeros. If they said find all the real zeros, then there would only be 2 answers, since these 2 would not be included. These are not real numbers. But in all, I've got 4 zeros. Okay, just a note, notice how the degree of the polynomial is a degree 4 polynomial. There's a connection between the degree of the polynomial and the number of zeros that you'll have. Okay. For example, f of x equals 2x cubed minus 3x squared minus 5x plus 6. There's nothing that is a common factor, and there's nothing that I can do to factor by grouping or anything like that. So I guess that if I try 0, f of 0 is equal to 6, so 0 is not a 0. F of 1 would be the next natural number to use. 2 minus 3 is negative 1, minus 5 is negative 6, plus 6 is 0. Okay, so f of 1 equals 0 means that x minus 1 is a factor. Okay, well, knowing that x minus 1 is a factor of f of x means that I can set 1 in the upper left-hand corner, and then I can use synthetic division if I want to divide this out. Bring the 2 down. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 1 is negative 1. Negative 5 times negative 1 is negative 6. Negative 6 times 1 is negative 6. 6 minus 6 is 0. I get 0 left over. Well, that looks good because that should make sense because x minus 1 was a factor. You see, if if x minus 1 were not a factor, I would not get 0 left over. Okay? So now, more importantly, I need to know what the expression is to the left of 0. When I divide these two expressions, 2x squared minus x minus 6 equals 0 is what I get. And if I cross multiply on that, f of x equals 2x cubed minus 3x squared minus 5x plus 6. Okay, now the plan here, now that's exactly what I had written there, is to factor this. Okay, and I've started to factor it as x minus 1 times 2x squared minus x minus 6. 2x squared minus x minus 6 factors further as 2x plus 3 times x minus 2. And so x equals 1, x equals negative 3 halves, and x equals 2 are the three answers. By the way, note that I've got a degree 3 polynomial and I've got 3 answers. Okay. Let's look at one more here. F of x equals x cubed plus 4x squared minus 5. Well, f of 0 is negative 5, so 0 is not a 0 of f. If I try 1, though, 1 plus 4 is 5 minus 5 is 0. So f of 1 is 0. X minus 1 is a factor. Okay, so I would want to take f of x and divide by x minus 1, and I've done that. I'm using synthetic division here. 1 is the 0. Okay, so 1 is going to be the number that goes in the upper left-hand corner of this table. 1, 4, 0, negative 5. 0 is because they've got a 0 in front of x. Okay, so I can bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. Times 1 is 5. 0 plus 5 is 5. Times 1 is 5. Negative 5 plus 5 is 0. That looks good. Anytime that the 0 is a 0, you get 0 left over. That will always happen. So I probably could have expected that, before I even did anything. Up here, knowing that f of 1 equals 0 tells me that I should have 0 left over when I divide. So when I divide these two quotients, I get x squared plus 5x plus 5 with a remainder of 0. Okay, f of x equals x cubed plus 4x squared minus 5, that's what I've got there, equals x minus 1 times x squared plus 5x plus 5. Well, if I set these equal to 0 and solve further, x equals 1, that was easy enough to get by guessing and checking. F of 1 equals 0. Now the other two zeros are going to be right here. X equals negative 5 plus or minus the square root of 25 minus 4 times 5 is 5 all over 2. And so x is equal to negative 5 plus or minus root 5 all over 2. Okay, I've got 3 answers total. Okay, and again, I've got a degree 3 polynomial. Now there's a connection between the degree and the number of zeros that you'll expect to have. They will always be the same. Always. Okay, so let's go to this fundamental theorem of algebra. Every polynomial function of degree n has at least one complex zero and has at most n complex zeros. For example, suppose n is 2. Okay, so you got a quadratic equation. Well, a quadratic always has 2 zeros. Always. You might have 2 different numbers. You might have the same number that repeats, but it repeats. Okay, so you got 1 0 that repeats twice, meaning that you got 2 zeros. Okay, n is 3. We've looked at a couple of ones with n being 3, right there. Okay, right there. We got 3 zeros. Okay, here's n equals 4. We have 4 zeros. Okay, so whatever n is, that will tell you the number of zeros that there will be. Find all the zeros. F of x equals x cubed minus 3x squared plus 4. Okay, well, if I try 0, f of 0 equals 4. 0 is not a 0. F of 1 minus 3 is negative 2, plus 4 is 2. F of 1 equals 2. So f of 1 is not a 0. How about f of negative 1? Negative 1 minus 3 is negative 4, plus 4 is 0. So f of negative 1 is 0. That tells me that x plus 1, x minus negative 1, is a factor. Okay? Now, knowing that x plus 1 is a factor means that negative 1 is the 0, and so 0 will be left over. Okay? So let's check it out. If I divide 1, negative 3, 0, and 4. That's what I see in front of the terms there. So 1 is going to come down. 1 times negative 1 is negative 1. Negative 3 times negative 1 is negative 4. Negative 4 times negative 1 is 4. 0 plus 4 is 4. Times negative 1 is negative 4. 4 minus 4 is 0 left over. That's something I could have expected early on before I even did any of this. Okay, knowing this right here, f of negative 1 is 0, tells me right away that the remainder is going to be 0. Okay, so I've got f of x divided by x plus 1 equaling x squared minus 4x plus 4. Okay, if I multiply both sides by x plus 1, then f of x, which is x cubed minus 3x squared plus 4, that's what I've got up here, that's equal to x plus 1 times x squared minus 4x plus 4. X squared minus 4x plus 4 factors as x minus 2 times x minus 2. That's equal to 0, so x equals 1, negative 1. X plus 1 equals 0 means that x equals negative 1. X minus 2 equals 0 means that x equals 2. Okay, now 2 has multiplicity 2. That is important. We need to think of this as a polynomial that has 3 different answers. I've got a degree 3 polynomial, so by the fundamental theorem, I know I've got 3 answers. Okay, all 3 of these numbers are in the complex number system. Negative 1 plus 0 times I, 2 plus 0 times I. Okay, so these are all 3 complex numbers. Okay, now they're real numbers. Okay, negative 1 and 2 again, but they're also complex numbers. How about g of x equals 3x cubed minus x squared plus 27x minus 9? Well, I should know right away I have 3 answers. Okay, because I've got a degree 3 polynomial. Now the first thing that I'm looking for is if I can factor. Okay, and I can factor by grouping. If I set the first 2 terms equal to one group and the last 2 terms equal to another group, then what's common to group 1 is x squared. That'll leave me with 3x minus 1 as leftover. 9 is common to the 2 terms there in group 2. So I'm going to have a 3x minus 1 coming from group 2, and that's equal to 0. Okay, 3x minus 1 is in common to these 2 groups. I can factor that out of the whole thing. And x squared plus 9 is the leftover. Okay, well, that means that x equals 1/3, or x squared equals negative 9, means that x is equal to plus or minus 3i. Okay, Now, all three of these numbers are complex numbers. 2 out of the 3 are very easy to see why they're complex numbers because I got the number I involved. 1/3 is also a complex number, though. Okay. Now, let me ask you this question. Suppose that we're going to do this problem again, and I could do like this method right here. Would I want to do that for this guy? The answer is no, I would not, because over here, you see, look at these numbers. I get -1 and 2 and 2 again. 1/3, maybe I get that. If I'm guessing and checking, I guess 1/3. I'm probably not going to guess 1/3 though. 3i and -3i, definitely not. Okay, so the way that we did this problem is the best way to do the problem. Okay, is really the only way to do the problem. Consider that. Consider what we are learning up here as a Plan B option. Okay, don't forget about what you've already learned when it comes to finding zeros and factoring. Okay. Yeah, let's do the conjugate zeros theorem here. If a plus b times I is a zero of a polynomial function, then its complex conjugate a minus b times I is also a zero. So there's no coincidence by why 3i and -3i are both involved. It has to be that way. It has to, because of the conjugate zeros theorem. Okay, 3i is the complex conjugate of -3i. Okay, here's another example. F of x equals x cubed minus 10x squared plus 29x. Well, x is in common to these three terms here. So I can factor that out. X times x squared minus 10x plus 29 equals 0. X equals 0. Okay, that's easy enough. And then x squared minus 10x plus 29 equals 0. So the only way to do that is to use the quadratic formula. That's our best option. And so the opposite of b is 10 plus or minus the square root of b squared. Negative 10 times negative 10 is 100. Minus 4 times a is 1, times c is 29. All over 2a. 2 times 1 is 2. 4 times 29 is negative 116. 100 minus 116 is negative 16. 10 plus or minus the square root of negative 16 all over 2. The square root of negative 16 is 4i. Okay, so 2 would be in common to these two terms in the numerator. I can factor that out, and that'll leave me with 5 plus or minus 2i. Again, it's not a coincidence why these two numbers are there. Okay, 5 plus I is there. 5 minus 2i is also a 0. Okay, so consider the conjugate zeros theorem as a possibility whenever you're asked to identify zeros of a function. Okay, and we'll go ahead and stop right there.